Small particles in oil arising from metal abrasion or soot can also cause wear. Piston liners are covered by a thin film of oil to enable smooth running of the pistons. The oil is maintained on the fine surface structure of the liners. Ultrafine particles in the lubricating oil act like sandpaper and destroy the surface through smoothing, and as a result, the running characteristics of the pistons deteriorate. Another effect is that more exhaust gas can enter the crankcase and the amount of blow-by gas in the engine increases. Fine particles also lead to wear in the main bearings when the engine starts and stops if the lubricating film has not sufficiently formed. A further effect is that ultrafine particles lead to increased oil viscosity. Oil thickens and is harder to pump. The result is inadequate engine lubrication and higher fuel consumption. Finally, the effectiveness of the oil additive is also compromised by soot particles. The centrifuge helps make the additive effective for a longer period. These fine contaminants in the lube oil are filtered out by the centrifuge fitted to the bypass. On the pump pressure side, part of the oil flow is directed to the centrifuge. The pump pressure forces the oil via a hollow spindle in the rotor. The rotor then fills with oil. In a way similar to the principle of jet propulsion, the rotor is then forced to rotate. Particles are displaced through centrifugal force and deposit on the rotor wall to form a filter cake. After separation, the oil leaves the rotor through tangential nozzles. The centrifuge is opened and cleaned according to the specifications of the engine manufacturer. The oil is directed to the oil sump. The centrifuge has a direct influence on the economical operation of the engine. It significantly reduces engine wear, leads to a longer engine life, and reduces the costs for lubrication oil.